So hello everyone, welcome back to another particular lecture series of our reagent chemistry course, and this is the class 11. So in our previous discussion we are talking about the homogeneous hydrogenation, especially the Wilkinson catalysis. So in this particular video we are talking about the heterogeneous hydrogenation, and we are mainly focused in the platinum, palladium and nickel based reduction in this particular lecture. Okay, so first let us begin with the heterogeneous hydrogenation. First let me tell you that what is the actually heterogeneous hydrogenation means. Heterogeneous means that the reactant and your catalyst both are in different phase. Okay, just if you just for a brief introduction that if you are actually seeing that a hydrogenation reaction by using palladium charcoal, then you may find that the your catalyst in the solid form, whereas the your reactant, the alkene, are mostly in the solvent, and the hydrogen are nothing but a gas. So basically there is a phase difference is observed between the catalyst as well as the reactant. So that's why actually it is called a heterogeneous hydrogenations. Okay, so it also have the similar properties like the homogeneous hydrogenation, or similar reactivity shown, like it is also done the synhydride synhydride addition takes place by this also. Same, the less substituted double bond reduced, less sterically hindered double bonds are more prone to do hydrogenation over the more sterically hindered bond. And also in the terms of stereochemistry, it also show directed hydrogenation in presence of a hydrogen bonded group such as the OH and NH2COOH group, and non-conjugated double bond redox in presence of conjugated double bond. This is the new something. So what should be the reaction? First let us understand, but before that, nickel, palladium, platinum have their own significance in the heterogeneous hydrogenation, such as that if you want to reduce any alkenes over carbonyls, then you will use the hydrogen palladium, because palladium has more affinity to bind with alkenes rather than carbonyls. However, if you want to reduce or hydrogenation on carbonyl groups but don't want to reduce the alkene group, then you can use the hydrogen platinum, because platinum has the higher affinity to bind with the carbonyl group, and the affinity have their own significance in this particular heterogeneous hydrogenation reaction mechanism that I will discuss in the next slide. So as I already discussed, the heterogeneous, it is reaction between phases where the catalyst are the mostly solid in nature, and so there is a adsorption based reaction takes place where the physio absorption, chemi absorption takes place. So what happened that this is the catalyst surface, and the hydrogen are come to the surface, and depending upon the active site present in the surface, it will actually show a physio absorption initially, then chemi absorption. So it will the hydro, and thus the hydrogen is absorbed on the catalyst surface, and then your olefin, or we can say that the alkenes are come here in this particular catalyst surface, or the closer proximity of this particular hydrogens to generate this particular complex. This is called the complex of alkene to catalyst. Now here this particular catalyst is palladium, and that's it is more affinity towards this particular olefin. However, if the particular reaction catalyst is platinum, then carbonyl group will get more affinity. So it will bind the physio absorption or chemi absorption takes place with the carbonyl group. However, we just restricted here because the palladium charcoal mediated heterogeneous hydrogenation is much more famous. That's why actually this type of complex is generated, and the reaction is the catalyst is a just I write here that catalyst here is palladium. Okay, so palladium, or co-catalyst is charcoal. So this is the catalyst, and the hydrogen absorption takes place, then also the olefin absorption is also takes place. After that, what happened that after doing absorption, this particular hydrogen is actually inserted toward one of the carbon center to generate this type of compound. Okay, and after that this particular uh, desorption takes place, where this particular hydrogen also attach in this particular carbon center, and also due to this type of syn type of addition, the always the cis product, or we can say the syn addition of hydrogen takes place with this particular reaction. Similar thing also happen in the homogeneous hydrogenation, especially in the Wilkinson catalysis part. Okay. So there is certain example of a heterogeneous hydrogenation. However, I want to say that not only that Wilkinson catalyst are actually do this type of hydrogenation. There are certain different homogeneous hydrogenation catalysts are there, but we are not discuss those things here. We'll discuss elaborately in our organometallic courses. However, now we are back with our heterogeneous hydrogenations. So here you can find that this particular reaction is there, and first the Birch reduction takes place. Now Birch reduction is done in the electron deficient alkene, but here there is a no aromatic compound is here. That means this particular negative electron from the Birch reduction is attack in the alpha beta unsaturation. This is the 1,4 addition that I already discussed in the Birch reduction lectures. It will attack here, and this goes up, and the negative charge is generated here. And now then, after taking another particular proton, here is also the initial radical came back to the, so the arrow is actually wrong here. So since it is a set mechanism, that means the arrow should be like this, then goes this, and those go via this, and after that taking another electron, it will generate the negative charge. Okay, and now this particular negative charge will go back, and here is say the methyl iodide is there. That means the alkylation takes place, and after that heterogeneous hydrogenation has been done. There is the hydrogen palladium charcoal to reduce this particular double bond to their corresponding single bond. So this is a classic example of how we actually merge the Birch reduction as well as the heterogeneous hydrogenation in one reaction. However, there is a single reaction is also there. Like here you can find there is a exocyclic double bond is there, and this actually getting reduced, and since it is a palladium, that means the carbonyl group is not reduced, it is keep intact. And here in this particular Norbornine system, okay, what happened that in presence of heterogeneous hydrogenation, you can find here this particular double bond is more substituted and this is the less substituted. So as per the selection rule, or we can say that the facts that it will go syn addition but less substituted double bond. So the product is this. Similarly, here also, if this particular part you can say now it is blocked, so that means the above attack is now sterically hindered. For that reason, actually, the lower addition or the endo addition takes place in the less substituted double bond. So this is the classic example of heterogeneous hydrogenations. And also there is another example of stereochemistry where the directed hydrogenation takes place. Remember that similar thing happened in the Wilkinson catalysis part also. Like here it is a hydrogen bonded group is here, and here also D2 palladium charcoal is taken to do the isotope leveling, and we can found that this particular product is generated exclusively where the stereochemistry of the addition deuterium are matches with the stereochemistry of the directed group, that is the OH. And there is some miscellaneous important examples also there, such as that cyanides are actually reduced to their corresponding amines. Azides also reduced to their corresponding amines. Nitro also reduced their corresponding amines. Okay, imines are also getting reduced to this particular thing. So this is the miscellaneous example, but yet important. Also, there are certain different type of reaction is also possible in terms of the heterogeneous hydrogenation, such as that the ether cleavage, like benzylic and allylic ether are cleaved via SN2 mechanism. So this is very important. Like sometime it is come in the question, like because the recent trend says that this type of question is repeated, that the reaction mechanism was asked. So this type of benzylic and allylic ether are cleaved via SN2 mechanism. So you have to remember this thing. Also, the CN bond cleavage can be done by using the hydrogen palladium charcoal, and cyclopropane ring cleavage is also observed. So this type of reaction you have to just remember. So with this, we have to end this particular lecture. So I hope this will be enough. And in the next class onwards, we are starting with the other hydrogenation reaction, such as the Rosenmund reaction, Raney-Nickel based reaction. This type of reaction we will discuss in the next class. So thank you for listening.